All right, let's talk about something a little weird. Today, we're going to celebrate a very special and very specific kind of day. It's something you have almost definitely experienced, but I'm guessing you never even knew it had a name. It's your Cosmic Ray Day, and we're going to figure out exactly what that means.
Just picture this for a second. You walk up to your boss and you say, "Today is my Cosmic Ray Day." I mean, it sounds like something out of a sci-fi movie, right? Maybe a great excuse to get out of work. But it's actually based on a very real and pretty wild phenomenon that's happening inside our computers all the time. So what is a Cosmic Ray Day? Well, it turns out the answer has everything to do with just how ridiculously fragile the data that runs our entire world can be. To really get this, we need to start with a bizarre but totally real-world example of data that has absolutely zero room for error.
And no, this isn't just some theoretical thing. We're going to look at a real piece of data that a computer can understand perfectly, but, well, it's basically hanging on by a thread. Its structure is the key to this whole problem.
Yeah, that. Believe it or not, what you're looking at is a perfectly valid chunk of JSON. It's just a bunch of nested objects where the key is a colon and the final value is also a colon. Super weird, I know, but a computer can parse it just fine, assuming every single character is exactly where it's supposed to be.
So what makes this thing so easy to break? Well, it has zero redundancy. Unlike a sentence, where you can have a typo and still get the meaning, here, every single character, every bracket, every quote is structural. If just one tiny part is wrong, the whole thing just shatters. It's completely useless. And here's where you can see just how fragile we're talking. In the binary code your computer actually reads, the opening curly bracket and the closing curly bracket are different by only a single bit. That's it. One tiny, invisible flip from a 1 to a 0, and that perfectly structured data turns into total garbage. That's what we call a bit flip. So, what causes these bit flips anyway? Well, they pretty much fall into two main camps. You've got your soft errors and your hard errors.
The difference here is actually super important. A hard error is a physical defect. It's just your hardware getting old and failing. Kind of boring, right? It's predictable. But a soft error, that's a one-time transient event. And for years, the prime suspect has always been the famous cosmic ray, a high-energy particle from deep space that zaps a memory chip, flips a bit, and then disappears without a trace.
So for a long time, the story was that these random cosmic rays were the main problem. It was a good story. But then, Google decided to look at the data from their own massive server farms, and what they found, well, it kind of turned that whole idea on its head.
And when I say massive, I mean massive. They analyzed memory errors across thousands and thousands of machines, which gave them a view into this problem that pretty much nobody else had at the time. What they found was pretty staggering. In any given year, a full 8% of all the memory modules in their entire fleet had at least one error. That is way, way more than anyone thought was happening. But the real shocker was what was actually causing them.
And this was the bombshell. The data was crystal clear. The vast majority of errors were from permanent hardware faults, those boring hard errors. That cool sci-fi idea of cosmic rays being the main villain? It was basically wrong. At the huge scale of a data center, it's just old-fashioned hardware failure that causes most of the trouble.
Okay, so if Google found that hard errors are the main problem, does that mean we can just forget about cosmic rays? Well, not so fast.
Here's the key difference. A hard error happens because the piece of hardware is already failing. But a soft error from a cosmic ray is totally random. It can strike any piece of hardware, even a brand new, perfectly healthy one. So while they might be rare overall, they're a risk for everybody. So let's actually run the numbers for a typical user.
Let's make a few simple assumptions. You've got a computer with 16 gigs of RAM, you use it for a normal work year, and we'll use the established scientific estimates for how often these cosmic ray bit flips happen. When you do that, you find something pretty amazing.
You are statistically likely to experience somewhere between 1 and 3 undetected bit flips caused by cosmic rays every single year. You are playing a cosmic lottery whether you know it or not. And guess what? You win every year. Now, before you panic and wrap your laptop in tinfoil, the vast majority of these flips happen in a part of memory that's not being used, or they corrupt some piece of data that's so insignificant you'd never notice. But the key phrase there is vast majority. Not all of them. Every once in a while, one of those particles from deep space just might flip the right bit at the wrong time.
So the next time your computer has one of those weird, unexplainable glitches, or a program just crashes for no reason at all, well, maybe it wasn't for no reason. Maybe it was just your turn. Happy Cosmic Ray Day. Now get back to work.